without making it into a function, but it's handy to use a function if you're going to use computer applications, because then it calculates it without you having to say, okay, now multiply by 7. You just do it, you put it into your equation. The last thing that I want to show you is if I have a graph that's already been given to me, I haven't had to graph it, it was just given to me as a graph, and I want to find, for example, f of -6. Remember, we think of it as f of x, and this graph here is, they're telling us this is f of x. So we know that whole f of x thing is the same thing as a y, and we know whatever is in here is our x value. So we can look at this and kind of pull it apart. I have f of -6 that I'm trying to find. That means at an x value of -6, what is my y value? So I can think about it as an ordered pair where my x part is a -6 and I have to find out my y value. So I come over here to the graph, and in the x direction, which remember is the horizontal axis, go 1, 2, 3, 4, 5, 6 in the negative direction, and then this is -6, 0. That's not on my graph. So to get on my graph, I have to go up 1, 2, 3. So I had to go up 3 to get to a point on my graph. Now I know f of -6 equals a +3. Let's do that another time. If I have f of -3, that means this is my x part, so come to my graph and go -3, 1, 2, 3, and then this time if I go up from this point, I'm never going to hit something on my graph. I'll actually have to go down and come to this point, and then I'll hit a point that's on my graph. So from here at -3 for my x direction, I go 1, 2, 3, 4, -4 for my y direction. And remember from before, this is just backwards of what we were doing before. If I start with this, I can write an ordered pair, and it would be the -3 for my x and then the -4 for my y. If I come over here and graph that, 1, 2, 3 in the negative direction, 1, 2, 3, 4 in the y direction, and I am at this point on my graph. One more time, f of +3, remember we're looking at f of x, so I want my x to be 3, so in the x direction I go 1, 2, 3 to the right, and then I'm looking where's the point on my graph, and I have to go up 1, so my f of 3 equals a +1. And here was my other answer right there. Now the last thing I need to find is the domain for this. This is a parabola, and the domain I can find by thinking about values of x, because these are the values of x. And if I'm over here at -infinity, will I eventually be able to move up or down and find a point on my graph? And because this is going at an angle up, 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 it'll eventually, even if I have to go a very long way, I'll finally eventually hit a point on my graph. So it does go all the way to -infinity. Everything's solid through here. There's a point, there's a point, there's a point. And in the same deal, because this is going on and on up at a very steep angle, but eventually over here at +infinity, I'll have a matching value for on my graph. Now the range, I'm thinking the y values. So if I'm down here at the very bottom at my -infinity for the y part, if I go to the left or to the right, will I eventually hit a point on my function here? And the answer is no. What about here at -10? No, still not. Down here, not until I get right to there will I have any points that are on my graph, and it'll be this lowest point right here. 1, 2, 3, 4. So we'll call that -5. And as I move up, it's still points. I'll get to eventually points on my graph here, eventually over here and here, and all the way up at +infinity. If I go to the right, I'll eventually hit a point here, and -infinity, eventually I'll hit a point. So all the way up to +infinity, it's always got a parenthesis, and for that -5, we're going to say that's exactly on the line, so it'll be a square bracket to include the -5. Alright, it's time for you to try one out. Pause the video. First thing I'm asked to find is g of negative 4. So remember, this is g of x, so my x is a negative 4. On my x-axis, I go 1, 2, 3, 4 right there. And I want to know, if I go down, no, there won't be anything. But if I go up, eventually I can get to this point. So I want to know, how far do I have to go up? 1, 2, 3, 4, 5, 6. So I have to go up to 6. So negative 4, 6 is a point on my graph. And for the x of negative 4, the y part is a 6. So there it is again. G of 1 then. That means from here I go 1 to the right, and I can see if I go up 1, I'll have my y part. And then g of 5, count over 1, 2, 3, 4, 5. And if I go up 1, 2, 3, positive 3, I'll have a line, a point on my graph. This is a function. It would pass the vertical line test. It's actually this one's an absolute value, and this one that we looked at before is a parabola. Okay, back to our absolute value. We found all our points. We just need to figure out domain and range. Domain, I'm looking at values for x, and over here at negative infinity, I'll eventually be able to get up to a point on my graph. So I'll say negative infinity, and then the same thing out to the right, positive infinity. It'll work all the way through. The range down here at negative infinity, no, it's not included. We don't have anything that's included until we get to here, which is going to be 0 for a y value, and then it goes on and on to infinity, and this 0 is included, so it'll have a square bracket.